Hello, this is a Module 3 Investigation 6. This is the last sections of the Module 3. So this is about inverse functions and reversing in the process. So number 1, the formula that determines the perimeter of the square P in inches where the squares aside the length S is known as P equal to 4S. So what thinking is involved in determining the side length S? So in order to find the side length S when the P equal to 20, the formula was P equal to 4S, but the P is a 20, and then we are looking for the S right now, so and divide by 4, so S equal to 5 inches. So what you do is plug it in 20 as a P because that's a perimeter, and then solve for S. In the B, when we solve the equation 20 equal to 4S for S, this is a one instance of the reversing the process. These formulas use the same process to determine the side length of a square S in inches given the following value of the square perimeter P in inches. So P is now 36. So for S, so S must be the 9. And 22 is the perimeter as equal to 4S. So for S equal to 22 over 4, which is 11 over 2, which is 5.5. 100 equal to 4S and divide by 4, so S equal to 25. In C, what process operation did you use to determine the square side of the length when specific value of the square perimeter P is known? So in this time, I divide the value of the squares perimeter by 4. D. Generalize a process you engaged in when answering part B by writing a formula then express a square side length S in terms of the perimeter P. So perimeter formula is P equal to 4S, which is P is in terms of S. Now we have to write the expression as S in terms of the P. So what you do is we just need to solve for S. So when you solve for S and divide by 4, and then you get the S equal to P over 4, and then this expression is exactly the S in terms of the P. And then D, how does the formula P equal to 4S and the formula S equal to P over 4 related it? Do they express the same relationship between the square side length and perimeter? So this is actually the same relationship, right? It's the same equation. Because what only the difference is for the P equal to 4S, and then S was input, and then P was output. But when you have S equal to P over 4, now the P is the input, and then S is output. So what happened is input and output is interchange each other. All right, so let's look at the things in the box. So in the box, if f of s equal to 4s, then the value of the square side length in inches is input or put in a function. Applying to the function rules, 4s determines a value for the square perimeter. So p of s is inches. So we can use the image of the function machine to evaluate the f of 8, and we input a particular value of the 8 in for s and apply the root of the f, which is we multiply 4 times of a, obtain the value for the perimeter, which is f of a equal to 32 inches. So this is actually the input as the way it is. Okay. All right, let's go to the number 4 for this problem. Oh, before that, and okay, so the next, actually the box is telling you about. Now, what if you have a g function as p's input, and then you try to solve it out the side, which is you put the input as a p, and divide by 4, and then you get the size comes out. Okay, so that's possible to do. So in example 4, all right, yeah, when traveling outside of the United States, it is often useful to be able to determine the temperature in Fahrenheit degree given the temperature in Celsius degree. The standard formula for the determining the temperature in degree Fahrenheit F when given the temperature in degree Celsius C is this form. So we need to use those formulas. Okay, this is the conversion form. So Fahrenheit is always equal to 9/5 times of the Celsius temperature plus 32. So in A, determine the formula that define the degree of Celsius C in terms of the degree Fahrenheit F. So which is, we're going to solve for C this time. So F was 9/5 C plus 32. And then we're solving for C. So in order to solve for C, you need to subtract 32 first, which is I got F minus 32, which equal to 9/5 C. And then in order to find the C by itself, we need to multiply by 5/9 both sides, which is multiply by 5/9. And then I got 5/9 of F minus 32, which is a 9 cancels out, 5 cancels out as a 1, so equal to C. So your C is now 5/9 of F minus 32. Okay, all right, so that is the formula, which is the C in terms of F. In B, define the function G that determine the temperature in degree Fahrenheit in terms of the temperature in degree of Celsius. So I want to say that the F is the original function 9/5 C equal to 32. So instead of the F function, I'm going to call this is a G function. So G of C is 9/5 C plus 32. So you can call the function form. And then C, define the function H, determine the temperature in degree of Celsius in terms of the temperature of degree Fahrenheit. So which is I have a C is, which is you find out the degree of in Celsius from the Fahrenheit. And then but instead of the C, I can say this is the H of the F, which is 5/9 times F minus 32. So what does in D, what does G of C represent? What is the H of F represents? Which is a G of C represents the degree, hold on a second, let me put it this way, represent the temperature in degree Fahrenheit. When the temperature in degree Celsius is C, and then H of F, which represents the also temperature, but in this time is the degree of the Celsius, because this is the same as a C and this is the same as a F. Okay, all right, so determine the value of the F. So now we need to use a proper function to figure it out. Okay, so the first one is a G function. So I'm going to use a G function. So G of 100, which is the G function is going to be you're looking for the Fahrenheit, right? So Fahrenheit, which is the use of C, which is 100 is a Celsius. So 9/5 multiplied by 100. C is 100. Okay, let me put this 100 here. So 100 plus 32, and then you get the 212. And then now second one is H function. So H is Celsius. So H of F is 212. Then you use this function, right? So you got 5/9 of F is 212 minus 32, which becomes 100. Now, we want to talk about the composite functions. So, in 3, we use the inside functions. So, g of 100. So, we already have a g of 100 here. So, g of 100 is right here, which equal to 212. So, you just need to put h of 212, but we already had it, which is in 2, right? h of 212 is the same as 100. And then the number 4, which is we need to find the h of 212, which is g of h of 212. We already had it. H of 212 is 100. And then also g of 100 is 212. So this is what happened. All right. So, yep, that's for number 4. And then I need to go to the we want to talk about inverse functions. So we already talked about the inverse function. So what are the inverse function? When looking for the perimeter for from the square is a 4s, and also s equal to p over 4 is inverse functions. These two are the inverse functions. So what's the inverse function happens? If you have p equal to 4s, which is s is input and then p was output. But when you have an inverse function, now p is the input and the s is the output. So this is it. So two x's have been interchanging. So in order to do that, number 7, we have actually the step to use to find the inverse function. So let me put down for you on the another page here. So if I go here to get the notebook. All right, so here's a step. So there's a steps for finding inverse function. So number 1, we need to replace f of x with y. Number 2, we need to solve for x. I think that's what they do. We need to solve for x for this case, okay? All right, so let's go back to our problem. So, but they already have a y or a w, so there's no function, okay? So you just need to solve for other variable, so x. Both sides, so y plus 8 equal to 2x, and divided by 2, and then switch the two sides, x equal to y plus 8 over 2. So that's actually we call the inverse function. We're solving for r this time. So multiply 4 both sides. So I got 4w equal to r plus 19, and subtract 19 both sides. We got 4w minus 19, which is r. Now r is 4w minus 19. That's the inverse function. So for x. So this time x is on both sides. So I want to actually multiply by x both sides to get rid of the fraction. So I got xn equal to 2x plus 6. And then I need to solve for x. So I need to put the x term together. I got xn minus 2x equal to 6. Now I need to put the 1x, which one way is a factoring. So factor the x out. I got n minus 2 over 6. And divide by n minus 2 both sides. And then I got x equal to 6 over n minus 2. So this is the inverse function. And also inverse function notation is we call this form. It's not a negative 1 degree, okay? So this is the inverse function notations. So you can use this way. All right. All right. So let's take a look at the number 9. So in number 9, we want to evaluate the following, okay? So you got to see what it is, okay? So f of 0, which is 0 is anything is actually the input, but especially the normal function, anything number inside is the input. So input is always, this is the input. So when you have input, you're looking for output from those functions, okay? So the A has a function f, so I need to look at the 0 in the input, and then function f give us a 4. So this is a 4. Now, do you see the notation of here is inverse, right? This is an inverse notation, right? Okay, which means, now be careful. This is actually the output. So you're looking for the input for the g function. So you need to find the 3 from the output. This is the output and this is the output for the f. So 3. So what's the input? Input is always just x by itself. So it's negative 1. So negative 1 is the input. And then, so this is also the talking about the inverse, right? So this is must be the output. So when you have output for the g function as a 0, which is right here, and then what is the input? Input is a 3. So this is equal to 3. And then the last one is also the inverse too, right? So which means negative 1 must be the output. So these two are the output. So when you have output of the negative 1 from the function f, which is negative here, and the input is a 1. So this is equal to 1. Okay, so and then composite functions, if the two functions are composite, if the function is a inverse function as a composite, always whatever inside you put in, it comes out as it is. Okay, so inverse with a function a should be come out as a excuse me, function with the inverse, function composite with the inverse must come out as a b, come out as a b. All right, let's look it up, the number 12. So you got to be carefully to find it. Okay, so in the table, this is input and these two are the outputs. Okay, so you need to know what is the number presents. Okay, so 3 represent the output because there's a inverse function notation. So because it's the output, so we have to find the 3 in the output in G. So 3 is right here. So what is the input? Input must be the negative 1. So this is equal to negative 1. In B, inverse, which is this is the output. So output for G is the 0 is right here. Input is 3. So equal to 3. And so now this is a composition. So you gotta do as a one at a time. So what you need to do is, okay, we gotta take care of G of 2 first. So G of 2 is, which is a 2 is input because this is not an inverse notation. So 2 is input. So 2 right here, use a G function should be negative 1. So this is equal to negative 1, which means now you can say inverse of f of negative 1. Now the negative 1 is output because inverse. So output of negative 1 is in the f function is right here. And then what's the input? So input is equal to the 1. So this is equal to 1. So this whole thing equal to 1. And then this time, so 6 is output for the f function. Whatever you're going to find it. And that will be the output for the g functions. So G inverse. Now we're looking for the input for the output 6 of the f function. So you need to find the 6 from the output, and input is a 2. So input is a 2. And also 2 is also the output to looking for the input for the inverse function. So 2 is output, input is a 0. Okay, so this is how you use a composition and then inverse function. All right, number 13. Note that the inverse relation of function might not be a function itself. Given the function f, define the f of x equal to x squared with the y equal to f of x. Complete the following, the evaluate the f of 2 and f of negative 2. So I want to find the what is f of 2, which is this is input. Input is always from the horizontal axis right here. So 2 is right here. And then you're looking for output, which is a graph. So it's a 4, isn't it? So equal to 4. And then now f of negative 2, which is x is now negative 2 right now, right here. And then you go up to see that same as a 4. So it's okay. It's a possible. you might can get the two same output from the different the x input. So explain why inverse notation, that is f's inverse function, is not a functions. So in this time, okay, so because in order to be a functions, okay, so this is actually the function because when you put the vertical line, there's only the one in a set. But in order to be the inverse be a functions, you use the horizontal line test. If you use horizontal line test, means you put the lots of horizontal line, but do you see that there's a more than one intersections? Because of that, the inverse is not actually the functions. So the inverse in here, so f is a function, but inverse is not a function. So consider g of x equal to x squared where the domain of the g is restricted. So now we're gonna only using the positive side. So explain why g's inverse is a function right now. So positive side means on the plane, you're only gonna use this one, which means in this one it passed actually the horizontal line test because only the intersection you can see is right here, right? Yeah, so that's why it is a functions, okay? Because the each of the x value only the corresponding to the one y value. And then write the formula of the inverse gives the domain and range, okay? So which means now g of x equal to x squared, right? But we only use x is a greater equal to 0 this time, right? And then if you do that, then if you find the inverse, which is y equal to x squared, and then you're solving for x, which is if you put the square root on, it's a plus minus, and then x equal to the plus minus square root of y. But we can take the two different y's, right? So we have to say x equal to, we only take the x equal to square root of y, which makes y must be greater equal to 0, and also x must be greater equal to 0 too. So this is a domain, and this is a range. Alrighty? Okay, so I think, yeah, that's all. Alright, thank you for listening.